Hi, everybody. This is Chris Fitzgerald for Scorbit. Welcome to today's webinar. Today, we're going to be looking behind the scenes of an iPad app at Audio for iOS. Now, we have a lot of material to get through today. If we have time at the end, I'll open it up for Q&A, but we may not have time. So during the webinar, jot down any questions that you have. And if we don't have time to get to them in the Q&A, you can email them to me at Chris, C-H-R-I-S, at Scorbit, SCORBIT.org. And what I'll do is put together a webinar FAQ and email that out to everybody. So just jot down your questions as we move along. So for today's webinar, what we're going to be talking about is iOS and the App Store. We'll get into assets and digital audio. We'll talk about app project management. And then we will get into sound effects and music creation for iOS. So first off, iOS and the App Store. Now, iOS is, of course, the operating system for Apple's mobile devices. iOS runs on iPhone, iPad, iPad mini, and iPod touch devices. And we are currently on iOS version 7. I assume all of this is probably not news to all of you watching. So the thing about this industry is that it's really exploding. It's taking off. So if you are a composer or sound designer and you haven't considered looking for work in the mobile industry, then check out these numbers. There are currently 900,000 apps in the App Store, and that's just the Apple App Store. The Apple App Store has seen 50 billion downloads, half of those since 2011. So the number of downloads is really growing exponentially. There are currently over 600 million iOS devices out there in the world. And to date, developers have earned $10 billion. That's billion with a B. So really not bad for an industry that didn't exist before 2007. So this whole industry gives you composers and sound designers really a lot of opportunity to find work. So we're going to take a look at some developer tools for iOS. Now, perhaps you're not interested in finding out what it takes to become an iOS developer, but the thing about it is it's really easy to get into. And as a composer or sound designer, knowing some of the tools of the trade for developers, knowing a little bit about how to implement audio into an iOS app can really give you a head start and really make you desirable to work with. So tools of the trade for iOS developers, they write their apps on a Mac running OS 10.7 or later. Now, of course, Apple would want you to write apps on the Mac. That really only makes sense. They use Xcode and the iOS software development kit. Both of these things are free to download, so you can download Xcode and you can check it out and just sort of see what it takes to get a game off the ground. There are tons of great tutorials online with how to do this stuff, and you can really develop a simple hello world. That's what they call those apps that just have a screen printout of some text. You can develop a hello world app fairly easily, and it's worth the time investment to learn some of this stuff. So it's free to make an app. In order to submit an app to the App Store, you have to be part of the iOS developer program, which is a $99 per year fee. And you can find out about all of this stuff on Apple's developer website right here, developer.apple.com. So let's talk a little bit about the App Store. Now, the App Store is the only place to distribute iOS apps. Submitted apps must be approved. So believe it or not, every single app in the App Store has gone through the approval process. even some of those really horrendous ones. And developers get 70% of the sales. So to put that another way, Apple gets a 30% cut. Whether you like this or not, that's just how it is. One way to think about it is you're giving Apple 30% to get worldwide distribution in a storefront that just reaches millions of people. So, maybe that's worth the 30%, but that's how it is. So can't be helped. So let's get into assets and digital audio for iOS. So what is an asset? An asset is an individual piece of digital media used in the creation of a larger production. So in an app, all the audio files, all the images, all video files are assets. So what we're interested in today is audio assets. And audio assets can really be broken down into two main categories. There's sound effects assets, which is often abbreviated as SFX, and there's music assets, which is often abbreviated as MX. And there's also UI, which is user interface audio assets, and I'm just going to lump those together in with sound effects. So among those sound effects and music assets, there's a couple different types. There's one-off assets, which have a defined start and end and just play once. And essentially, one-off assets are assets that are not looped. And then there are also looped assets that play continuously, often in the background. So let's get into that a little bit deeper. One-off assets are generally object-oriented. Most one-off audio assets are object-oriented, though not all of them. And being object-oriented, they could be interactive. So anytime you do something to move a character or push a button or just interact with something on the screen, generally there will be feedback in the form of an audio asset that will let you know what you're doing and what you're accomplishing. There are also object-oriented, non-interactive assets. And this could be character voiceover, or it could be sound effects that are triggered by some sort of automatic object movement. So it could be something that happens that's not interactive, but is in fact coming from an object. And that would still count as a one-off object-oriented audio asset. So then there's looped audio assets, and these can be ambiances, whether it's maybe the environment is a city and there's traffic noise or things of that nature. It could be a looped ambience, or it could be looped music that goes on. So let's take a look at an example. Now, this is from a popular iOS game called Angry Birds. Perhaps you've heard of it. So this is just kind of a short, I think it's only like 10 seconds long, clip from Angry Birds. And pay attention to all the audio assets that you'll hear. You'll hear a looped ambience. You'll hear one-off object-oriented assets that are interactive, and also some that are non-interactive. And then you'll also hear a one-off music asset when the level is completed. So here we go. Okay, so when you pull the slingshot back, you hear the stretching of the rubber band, and then when you release the bird, you hear like a kind of a sound effect, and then when the bird hits the wood and glass, you hear collision sounds. Then you hear the bird celebrating. So those are non-interactive one-off assets, and then again, there's a like forest ambience playing in the background, and then the the music at the level completion. So listen back again for those. I'll just play this clip again real quick. Man, those birds are angry. All right, so let's get into some about digital audio. Digital audio must be coded to be stored as data. And when digital audio is stored as data, it's just bits, just a long string of ones and zeros. And then in order for digital audio to be played back, it must be decoded. And this process has given us the term codec, which is short for coding, decoding. So among digital audio, there are several different file formats and data formats, and this can get very confusing, but let's delve into it some. The data format is the codec. The data format is the raw audio data that is coded and decoded. And then the file format is also often referred to as a container file that stores this raw audio data, or that stores the codec. So what's confusing about it is there can be several different combinations of codecs and file formats. And some of them are accepted in the iOS operating system, and some of them are not. We are simply going to talk about the preferred audio formats for iOS. So we're not going to get into every single potential audio format that can be put into an app. We'll just talk about the preferred ones. And now these are the preferred audio formats as Apple has laid them out. So again, iOS apps accept many different types of file and data formats. And the preferred ones for higher quality, and actually real quick on this point, you as a composer and sound designer working on a mobile app will constantly be fighting a battle between having good quality assets and having assets that are small in size. And I don't mean fighting a battle with the developer. I just mean constantly making decisions about where you can sacrifice quality in order to make assets even smaller. So Apple's recommendation is to use higher quality for sound effects or shorter audio assets. And the preferred format is an uncompressed PCM, which is pulse code modulation. And pulse code modulation is just the way that uncompressed digital audio files are created. And they recommend that you put them in a core audio format or CAF container. For less memory usage, and this could be for things that are music or longer audio assets, probably your stuff that loops in the background, they recommend that you use a compressed IMA4 data format in a CAF container. So there you have it. There's Apple's preferred audio formats. We'll talk a little bit more about how you can get your audio files into that format. So there are several different considerations I want to walk you through when you are creating audio assets for iOS and for mobile in general. There's hardware versus software decoding, and this is how the device plays back the audio files inside an app. Hardware decoding is much more efficient, but it is limited to one audio stream, and what that means is only one audio asset can be hardware decoded at a time. So that can be a problem if you have music and sound effects playing at the same time, or if you're working on an app that has some audio components to it, but the music is still playing, like maybe Pandora or just the music app on the iPhone. So some formats that are eligible for hardware decoding are AAC, MP3, and Apple Lossless. Software decoding is much more versatile but is more taxing, meaning that the app and the device have to work quite a bit harder to decode those audio assets. But if, again, you need things to be, if you need to have more than one audio asset playing at a time, then you have to make them in a format that can be decoded by the software. And so, again, they recommend IMA4 for compressed assets to be software decoded, or PCM, again, for uncompressed assets wrapped in a CAF container. Another major consideration is the over-the-air download size. And right now, this is currently at 100 megabytes. Now, what this means is that any app that is over 100 megabytes cannot be downloaded over cellular data. It has to be downloaded over Wi-Fi. And this is a big problem for developers because it limits the accessibility for consumers to get their apps. So developers are, it's very much in their interest to have their total app size be under 100 megabytes. And there's some ways around this. You could have the initial app size be under 100 megabytes, and then there could be additional download content after they get the app. But at any rate, the big battle, as I was referring to earlier, is to get your assets really small. Now, as composer and sound designer, you'll be lucky if the developer gives you even half of that for the audio assets. You probably won't even have that much to work with. So because of that, you want to crunch your assets, make them as small as possible, but still good quality. And some ways to do that, you can reduce the sample rate. Now, sample rate is the number of samples per second in digital audio. And one sample is just an instantaneous snapshot of an analog audio waveform. And you take all those snapshots and you put them back together, and at higher sample rates, you more faithfully render back that analog audio waveform. Now, the way that sample rate works, the highest frequency that can be represented in an audio waveform is half the sample rate. So if that's the first time you've heard about this, then look it up. It's called the Nyquist theorem, Nyquist, the Nyquist theorem. And what that means is that at a sample rate of 44.1 kilohertz, which is CD quality, the highest frequency that can be played back is 22 kilohertz, 22,050 kilohertz. So that kind of wastes some space because your average human hearing range is 20 hertz to 20 kilohertz. If you're lucky, if you've been to rock concerts in your teens, then it's probably more like 18 kilohertz at the top. So from 18 to 22 kilohertz, that kind of just wastes some space. So if you have a sample rate that's 32 kilohertz, then the highest frequencies that can be played back are 16 kilohertz, and your asset size is going to be reduced considerably. Now, this isn't necessarily ideal, but again, you're going to be in this constant battle between having good quality assets and having them crunched down and small. But that's one way you can crunch them down. You can also reduce the bit depth. What bit depth is the number of bits that are used to describe each sample. So some typical bit depths are 16, which is CD quality, and 24. What you can do is reduce 16 bits down to 8 bits, and you'll cut the asset size in half. So what you might want to do is take your assets that are less important and reduce those down so they're smaller, and keep the important assets at a higher sample rate and higher bit depth for better quality. And then another thing you can do is use mono assets whenever possible. If a sound effect is not, if it's not necessary to be placed within the stereo spectrum, then make it mono. Now, some that you might want to keep as stereo Maybe there's a car racing by in the app and you want to have it pan from left to right. In that situation, you'll want that asset to stay stereo. But if you use a mono asset, then that only uses one channel of audio rather than two, and that will also cut it down in half. So some things to consider. So what's important about this is your assets can be different sample rates and bit depths and can be mono or stereo, and the app will play them back correctly even if they're all at different rates. Some other considerations: there are some compressed formats, particularly MP3s, that put a little bit of padding at the top and the tail of the asset. So this adds a little bit of time at the front and the back. And what that will do is it will wreak havoc on your looped audio assets. So while you can use MP3s in iOS apps, if it's a looped asset, then you don't want to use that format. And there's other formats that do this. If you need a compressed looped format, again, Apple recommends the IMA4 data format, and you shouldn't have any problems looping those assets. And then lastly, for audio asset considerations, is format conversion. Not all of your DAWs will let you export audio in those different formats. And so what you can do is export your assets probably in some kind of PCM uncompressed quality format, maybe WAV or AIFF or CAF if available. And then on the Mac, there's a command you can use in terminal called audio file convert, AF convert. If you haven't done any line code kinds of things like this in terminal before, it's a pretty steep learning curve, but there are some tutorials online to walk through it. But it's great. You just identify a file input and output, and you specify what you want the format output to be, and it will convert an audio file for you. And you can even batch convert stuff, where you can take a whole folder of assets and automatically convert them so they're IMA4 in the CAF container and so on. If you don't want to get into terminal, you can also check out some apps that will do this. Like there's one called Switch that I've checked out that's pretty cool, that does some batch conversion stuff. And if I remember right, I think it's $29, so that's fairly affordable. But here's the URL to check out Switch. So now let's go over some considerations that are just inherent to mobile devices. There's frequency capabilities, and what I mean by this is what frequencies the speakers in these devices can play back. And you probably noticed that iPhones and iPods and iPads, they're pretty mid-rangey. They don't have a lot of bass frequency. They don't have a lot of high end. So if you have a lot of low end in your audio assets, the speakers in these devices are not going to be able to faithfully play them back, and they'll also actually probably cause the speaker to distort a little bit. So what you might want to do is just roll off pretty much everything under 200 hertz and maybe everything up above 18 kilohertz. Anyway, and you can do that with an EQ on the main output to roll that off. And now again, that's not ideal for making them sound as good as possible, but just keep in mind that you're trying to make it sound as good as possible on the device that it's going to be played back on. You'll also want to consider the environment that your user is in when they're playing the game. It could be a fairly noisy environment, or they might be listening to it on those crappy earbuds that Apple gives you that everybody uses. So those are some considerations. Most important thing before you deliver all of your audio assets is to test them out. And some things I recommend when you're testing out your audio assets is to crunch them down, take a listen, and crunch them down again, and then take another listen. And so what you want to do is with each asset, especially if you really need to save on space for the overall size of the app, you can take each asset and kind of find the breaking point where the quality just really degrades down and isn't good anymore, and then sort of set your threshold just a little bit above that so that it's decent enough quality. And especially again with your assets that are not as important, you'll want to make those as small as possible. So crunch them down, check them out, crunch them down, check them out. And then another thing you can do is create a simulated mix of combined assets. Now, if you're actually going to be the person implementing the audio into the app, then you'll just put them in the app and test them out that way. But if you're not going to be that person, then create a mix. And what's helpful about this is you can listen to one asset by itself all you want, and it could sound great. But if you have multiple sound effects playing at the same time, maybe over an ambience loop and a music loop, you want to make sure that the levels are all balanced correctly and that everything sounds really good together. So the easiest way to do this is just open up your DAW and randomly drop in assets that are all part of the same level or environment. And you can copy and paste them so that they occur a couple different times, and then just loop it and listen to it back again, and test it out and hear how everything sounds together. Then you want to load the assets onto your mobile device, and this is really the most important thing with testing. You got to check out how it sounds on the device. And the easiest way to do this is just throw them into a playlist in iTunes, and then throw them onto your phone or your iPad that way, and then just play them back through the music app on the device, through the speakers, and also through those crappy earbuds. And then you'll also want to listen to it in a noisy environment. So your user might be playing a game on a subway without their headphones, and we all love that person that gets onto the subway and sits down and is playing a game really loud without their headphones. But that's a fact, that your user might be in that environment. So you'll want to make sure that that some of the assets are able to punctuate through that, especially buttons and stuff like that. You want to make those nice and clear and crisp. Any of those UI assets, it's important that your user actually hears them. So let's get into project management stuff. What you'll want to know from the developer before you embark on an app project. You'll need the design document. You will need any concept art that they've put together for the app. You will need, if they have it available, an actual working prototype of the app. So let's get a little bit more into those things. What the design document is an exhaustive report on the app that's created by the development team. Now, they may have put this together before they even started working on the game in order to pitch the game to investors. Likely this document will change once they start working on the game, and once they, whenever one of these projects starts, they make decisions and change their mind on various things, and then at that point they'll have to change the design document. But the design document will likely include the story of the game or the app, any background information on important characters. It will have any level or environment design. It will have information about gameplay, like for example, what weapons does the character use? How do they move around? How do they walk? Those kinds of things. How do they pick things up? Do they swim in the app? All those kinds of things. It will have information about what the art and what the sound and music are going to be like. What will the app sound like? They may have some temp examples of music, that kind of stuff. And then that will also lay out user interface and game controls. Now, of course, on a mobile device, that is the screen, and that is the user touching the screen. But if it's a design document for a console game, it might be what buttons on the controller affect the character in what way, and so on. So here is an example of a design document that you can check out if you want to note this URL and check it out later. It was a really long URL, so I crunched it down for you guys. I put it at tinyurl.com/design document example. And I think this is something from a project that somebody was working on at Tufts, if I remember right. So for concept art, this could be the environment. What does a level or a world look like? This could be a character. Now, if you're doing sound design for a character, you're going to need to know as much as you possibly can about that character. Maybe one of the characters is a robot. Well, you'll want to know, is it tall? Is it small? Does it walk? Does it move around on wheels? Does it move around on treads? Does it turn its head? All of those kinds of things you'll need to know in order to breathe life into a character. There will possibly be actual concept art screenshots from the app, and maybe even a complete storyboard of the entire app. So what happens at the beginning? What potential things could happen next? Do we ever loop back to the beginning again? Those sorts of things. And then if they have a working prototype of the app, then the only way they can distribute this to you is if you are in the developer program. So what this is about is that you cannot distribute an app except through the App Store. So before an app is actually available through the App Store, it can only be distributed amongst developers. So if you do a lot of work in this industry, you're going to want to pay that $99 a year to be part of the developer program, just so you can test out app prototypes on your devices. And again, you can check this out at developer.apple.com. So from all that information, you will build your asset list. So your asset list will help you determine the scope of the overall project, and it will help you figure out every single interactive element of the app and everything that requires feedback to the user. And from this, you'll get a sense of how much time it will take you to produce all this stuff, and hopefully then what you can charge for the project. Now, a developer that's ahead of the curve might furnish an asset list to you, but before you just accept it with blind faith, you'll want to look it over and make sure that the asset list makes sense to you. What you don't want to do is have a really long asset list and create all the audio assets and deliver them, and then have the developer come back and say, you know what, the app ended up being way too big, so we're cutting this list in half and we're only going to use half of your assets. You want to find that stuff out ahead of time. So have an in-depth conversation with the developer at the start before you determine what should and should not be on that asset list. So once you have your asset list, then you can start making the assets, and the naming convention is crucial. So you'll want to decide this with the developer, how the assets should be named. The most important function of asset names is to facilitate organization. There's a lot of people working on projects, and any one person, somebody that's coding it, or maybe somebody that's doing the art or whatever, might need one of your audio assets at a given time, and you want them to find it easily. Also, it's important that the names make sense so that the audio doesn't get implemented incorrectly. Maybe you have a weapon sound that one of the coders confuses with a footstep sound, and they implement it incorrectly just because your names weren't clear. So that could be a problem. So one way that you could name your assets is this way. Have it be location in the game, and then next the asset type, and then next the description of the asset. And it's important that you do not have spaces in any of the asset names, because they're going to take that asset and just drop it right in, and having spaces in the name can throw some things off in the coding language. So that would translate to something like this. This is an asset that I created for the app that we're going to take a look at momentarily. And this asset is used on page 3 and 4 of the app. It's a sound effect asset, SFX, not a music asset. And it is electricity. So here is that asset. I'll play it for you. Nice and short and sweet. Google Docs are a great way to facilitate communication amongst everybody on the team. First of all, they're free, and they are cloud-based documents, so multiple people can be working on a Google Doc at any given time. And this is great, especially if you're working remotely. Maybe you're actually, for this app project, I was working with people in LA while I was out in Boston, and we had no problems because we were able to work remotely in this way and communicate through a Google Doc spreadsheet that we created. But a Google spreadsheet is useful for communication, for signing off on assets, for ensuring that deliverables and deadlines are met, and making sure that, most importantly, that nothing is forgotten, that all the assets are created and delivered, and so on. So up on Scorbit, we have a tutorial on this called Game Audio Asset Management with Google Spreadsheets. And here is a screenshot from that tutorial. This tutorial was put together by Richard Ludlow, who is actually going to be speaking at GDC in a couple weeks. But if you want to check this out, you can at scorbit.org. You can sign up for a Scorbit membership to start for just $1, and I'll talk more about that at the end here. But here's a screenshot from that tutorial. Here's one of Richard's Google Docs on a project that he worked on, and you can see he's got columns for asset creation and what state each asset is in, whether it's been started, whether it's in progress, if it's pending approval or needing to be revised, and so on. And then he has a column for implementation, whether or not it's actually been implemented in the game or the app yet, what the state of that is, what type of asset it is, what the name is, all good information here. And another thing that's great about having a Google Doc set up is that if you have a question for the development team, you can post it up in there, and there's a great comments feature in there where they can answer your questions and vice versa. So a great communication tool. So great. Now we're going to take a look at an actual app project, and we will look at how to create a one-off and a looping audio asset. We will look at a layered composition. And what's great about the layering technique in interactive music is you can have different intensity levels. And so if there was a 3-layer composition, the bed or the base layer, we'll call it layer 1, could be the low intensity level. And this could be when a character is maybe just exploring an environment. And then the mid-intensity layer could kick in maybe when they start fighting enemies, and then the high-intensity layer could kick in maybe when they're severely injured and low on life, that kind of a thing. So the way that it works is the 3 layers all start at the same time, but 2 of them are muted at the beginning, and then they can fade in and fade out based on what's happening in the game. So we'll look at a layered composition that I did for this app. And then we'll also look at creating a more complex sound effect asset by layering multiple sounds together. So the app project that we're going to take a look at is called Where Do Balloons Go? An Uplifting Mystery. This was a really fun project to work on. It's a children's storybook that got turned into an app, and it was written by actress Jamie Lee Curtis, illustrated by Laura Cornell, made by the company Aran that puts out really great stuff. They're out in LA. And then I did all the music and sound effects for this app. So I took some video of just a couple segments of the app, some things that we're going to explore. So here is the app opening.
Where Do Balloons Go? An Uplifting Mystery. Written by Jamie Lee Curtis. Illustrated by Laura Cornell.
And then we will take a look at some object-oriented sound effects. In particular, I'm going to dissect this shooting star sound effect that you'll hear in a moment.
Oh boy, it sure is getting hot. Hey, I can see my house from up here.
And then just a moment ago, I was talking about the layering technique in interactive music. So for this app, I created a 5-layer composition. There's this scene where the balloons are dancing around, and actually they start stuck, and you touch them and free them. After you free a certain percentage of them, layer 2 kicks in, and then layer 3 kicks in until you have all the balloons dancing and all 5 layers kick in. So here is how that plays out. Okay, so let's take a look at these assets. Let's start with just editing some one-off assets. So I recorded. Actually, probably the funnest part of doing this app was they needed a lot of balloon squeak kinds of sounds, and so here I'll play a couple of these for you. They're pretty fun. And of course, they sound like farts, and farts are funny. But yeah, doing like balloon squeals was really fun. Um, and there were just some sort of balloon interaction sounds, like blowing up a balloon and deflating a balloon. So what I did was I recorded just a long section just messing with a balloon, and then I went in and edited out the best parts. And so here is a segment from the overall recording that I did, and then I'll show you how you can go in and crop it and edit it so that it works. Balloon blowing up. Balloon deflating. And you'll notice that I slated everything that I was doing. I said balloon blowing up right before I blew the balloon up. And that is really helpful when you're listening back to something, because sometimes you might forget exactly what you recorded, and maybe even when you listen to it back, you can't tell. So that way, that's what slating is. You just announce what it is that you're going to record before you record it. So I'm going to bring this into Logic, and we'll take a look at cropping out and doing some audio editing here. So I'll bring in the balloon Foley. Now I recorded this at 48 kilohertz. I'm going to change the project to okay. And it looks like I'm going to disable Logic's input device since we are doing a live webinar. I don't want to get any crazy feedback. All right. So I love Logic's audio editor, but you can do this stuff in Cubase, Digital Performer, Logic, Pro Tools, even Audacity, which is a free program that you can download. So here is this segment of audio. Actually, I need to send this out through the built-in output because of the way I have it set up. All right. Balloon blowing up. There we go. All right, now I'm going to open this up in Logic's audio editor, and I can select a segment here. Balloon blowing up. Not that segment. Now maybe I want that by itself, or maybe I want this section here. Now Logic does something great, which is it snaps edits to a 0 crossing point. Now let me tell you what that's all about. Let me go in on a section that's a little has a little more amplitude here. If I click and drag over a segment here and let go, it snaps to 0 crossing points, or points in the audio where there is no energy. There's no positive amplitude, no negative amplitude. It's a 0 crossing point. So if I play this back, that's such a small section. We're talking about milliseconds, but that will ensure that I don't have a click or a pop at the beginning and the end of the audio there. So that's a great feature because you don't have to zoom in real close to do it. Logic will just snap the edits to a 0 crossing point. Now with your audio assets, it's important that you tight crop them right to the beginning of when the sound starts. You don't want to include all this stuff at the beginning, because then the user will push a button and there will be a slight delay before the audio asset plays back. So let me grab this section for the balloon deflating. Get a little bit of the tail there. Great. And now in Logic, I go to Audio File, Save Selection As. And then again, I'll use the naming convention, page 03, sound effect, and I'm putting underscores in between there. And this could be balloon deflate 1, something like that. So that's how you would crop out a one-off sound effect. Let's take a look at creating a more complex layered sound effect. Okay, so I have the electricity sound effect. Let me play that whole thing for you here. And one more time. So this is actually made up of 3 elements. There's one moment in the app where you touch an electric panel and basically sort of short it out. And so the electricity surge here is track 1, and let's just listen to that by itself. Now I got that from a sample library. The other 2 I recorded myself, but here's just kind of a quick surge. The sparks here are, I went out to my car and put the jumper cables on the car battery and then just touched the ends together to get some sparks. One of those don't try this at home kinds of things. And then for broken glass, I just smashed a light bulb with a shoe, I think is how I got it. And got a great popping sound. So you'll notice that the sparks, I kind of took different segments of that recording and I cross-faded those together here. And so the total layered asset is this. So you can get pretty creative when you're building sound effect assets. And that kind of stuff is really a lot of fun to do. Let's take a look at what I want to do next. Let's look at that layered composition. Actually, I'm going to open up a brand new Logic document. And I'll bring in the 5 audio stems for my layered piece. And this actually imported the tempo information, which was at 220 beats per minute. So that's really nice. So I've got drums are layer 1, bass is layer 2, guitar is layer 3, sax is layer 4. So let me put those in order. Now this one tails out. So the thing that's tricky about exporting out your stems is getting them to loop correctly. That can be really challenging. And let me show you what I mean. I've got a little bit of a effect tail at the end there. So if I put the cycle mode on, which is Logic's looping feature, and play this back, I'm going to play just the last couple of measures into the beginning again, and we'll hear how well it loops. Now, there's a little bit of drop in dynamics just based on what is happening musically at the time. I'm not too concerned about that. What I am concerned about is making sure there's no click or pop at the beginning or the end of each of these stems. So what I would do is open up every single stem, zoom in at the beginning, and make sure they're at 0 crossing points. And the beginning of the drum's stem is at a 0 crossing point, so that's good. Now let me go here to the end, and actually the tail information is in there, even though, you know what I'm going to do is bounce these all in place, and that will cut out any information from the audio file that is not visible, basically. Sorry, I'm moving too fast here. That combined everything together into one piece. What I would want to do is loop these or bounce these all separately. You know, I'm not going to take the time to do that. Actually, the main thing I wanted to show you with this is a process where you take the reverb tail from the end of the file and have it play at the beginning of the file. And what that does is it makes sure that the loop is seamless. So it's really as simple as going to the end here of the loop, slicing the ending, creating a new track, and having the beginning line up there, so that the moment after the loop ends actually happens at the beginning here. And so that will blend really nicely from the end here to the beginning here. Hopefully that makes sense. So what you would do when you're bouncing out your stems is you could solo the tracks for stem 1. You could bounce. And while we're here, I just want to point this out. Logic has a great option called Bounce Second Cycle Pass, which sets it up so that you don't have to do that reverb tail chop that we just did. It would actually take the decay from the first cycle and apply it to the beginning of the audio file. So it just does it for you. Now that will only work if you're bouncing out in real time rather than offline. Now there's a lot of stuff there that could actually probably become its own tutorial, but I just want to point out one other quick thing here. So you do have some audio formats that you can export out, and these are the uncompressed file formats. So in Logic, you can bounce out in core audio format. You can't use the IMA4 format, so you would need some sort of conversion or use terminal to convert those audio files. So there was one other thing I wanted to show you. I wanted to talk about how to create a looped ambience. So we can do that relatively quickly here. So I have an ambience sound effect, and I got this from a sound effect library, and this audio file is called Concrete Jungle, so it's just some city noise. So I want to create a 30-second loop out of this audio file. So what I'm going to do is find, I'll just crop out a segment that I want. So I'll have it start here, and then I'll go to the 30-second location in the track and slice it there. So now I have 30 seconds of this audio file. Now, I can't loop it like this and call it good because it's not going to sound very good going from the end to the start. I'll show you what that sounds like right now. It's a little bit jarring because this girl starts squealing at the beginning here and she's not at the end of the region. So what I would do is find a moment in the file, in the audio, there's not a whole lot happening. And I'm just looking at the waveform here, and it looks relatively quiet here. And I'm going to slice it there and create a new track. Bring this to the beginning, this to the end, like that. Actually, I can put these on the same track. And create a crossfade here between the two. So that my loop point is inside the audio file. And then this actually ends continuously. It goes continuously here into the beginning. So let's hear if that sounds seamless right there. Okay, great. That didn't sound jarring at all. That seemed to work. And then let's hear the actual loop point at the end when it goes back into the beginning. Okay, totally seamless. So, great. So there's a lot of techniques that we just looked at. And what I want to tell you guys before we go is that we have some more tutorials on Scorbit. Scorbit is a community for film and game composers and sound designers. And we have forums on there, and we have tutorials on all sorts of different subjects. We have full all-out courses. There's a 6-part course on the art of film scoring and another 6-part course on game audio essentials that walks through a lot of these topics that we touched on in greater depth. And you can try out Scorbit for 7 days for just $1. And it's here at scorbit.org. So I hope you'll check it out. And please email me any questions that you have. We did run out of time, so I won't be able to do a Q&A. You can email me at chris@scorbit.org. And I hope you enjoyed the webinar. Thank you very much for your time, and have a wonderful day.